use the Kelvin scale. Heat flows from matter. From warmer to cooler object, heat is a form of energy. Temperature is a scale, and again, usually degrees Celsius is that measurement for that scale. Heat is an energy, typically measured in joules or kilojoules. The quantity of heat energy absorbed is defined as the heat capacity. When a system absorbs heat, its temperature increases. The increase in temperature is directly proportional to the amount of heat absorbed. The word heat capacity really is a proportionality constant. If I think about heat capacity, how much energy does it take to warm up an object? If I have a small amount of water or a whole lake full of water, how much energy is it going to take to raise this 1 degree versus an entire lake? The larger the heat capacity of the object being studied, the smaller the temperature rise for a given amount of heat. Water takes an incredible amount of heat energy to warm it up. Compare that to a metal, for instance. Copper or iron metal warms up very quickly with the temperature. The factors that affect heat capacity include, of course, what the object is made of and how much of the object you're measuring out. So the heat capacity depends on how much of the sample you have. 200 grams of water requires twice as much heat to raise its temperature as would 100 grams of water, that direct proportionality constant. It also depends on the type of material you're using. 1,000 joules of heat energy will raise the temperature of sand by 12 degrees, but the same amount of water only gets warmed by 2.4. Water has a much higher heat capacity than sand. How much energy it takes to raise a whole object by 1 degree Celsius. However, if we think about the term specific heat capacity, we narrow it down to a per gram. Heat capacity is an intrinsic ability. It does not depend on how much you have because it makes the race fair. It says for every 1 gram, how much energy is needed to raise that object by 1 degree Celsius. The term specific heat puts it in a per gram basis. The previous slide, that heat capacity, how much energy for the entire object to raise by 1 degree Celsius. Specific heat we see gets the symbol C, or sometimes I see it CS or CP for constant pressure or the constant system, specific heat capacity. And the units for that is joules per gram degrees Celsius. How much energy does it take to raise 1 gram of an object by 1 degree Celsius? If instead of the word gram, we put in the unit that the chemist often uses is a mole, we get the molar heat capacity. How much energy is needed to raise an object by 1 degree Celsius if we had an entire mole's worth? Pause the video here and just take a moment to look through some specific heat values, asking yourself, what do these numbers mean? What information am I gaining by looking over specific heats?